Hi, I want to extend our discussion of kinematics from a one-dimensional situation to an n-dimensional world. Now, in the physical world that we humans observe, we have a total of 3 dimensions, but this process would apply equally to 2 dimensions, or really any expanded dimensional system that we could come up with. Because kinematics is ultimately just calculus. And calculus was developed by Newton to describe motion and how motion changes. So we always start with a location function. And if we're in the 3-dimensional world, we often use vector r of t, where there's a function x of t showing how our x-coordinate changes in time in the x direction I hat, a function y of t that shows how our y-coordinate changes in time in the y direction j hat, and a z function, z of t, that shows how our z-coordinate changes in time in the z direction k hat. Now, the velocity is always the derivative of the position. But if we're taking a derivative of vectors, all that is an operation that just distributes to each term of our vector. So if we have 3 dimensions, we take the derivative of our x function with respect to time, I hat, plus the derivative of our y function with respect to time, times j hat, plus the derivative of our z function with respect to time, times k hat. So, just as I say in introducing vectors of all types, what happens in x stays in x, what happens in y stays in y, what happens in z stays in z. Now, that would give us a velocity function where we have an x component of our velocity that could be a function of time, I hat, a y component of our velocity as a function of time, j hat, and a z component of our velocity as a function of time, k hat. And finally, when we take a look at kinematics, we usually stop looking with acceleration. And acceleration as a function of time is the derivative of velocity. And the derivative of velocity is the second derivative of our position function with respect to time. And again, that all happens term by term by term. So we take the derivative of our x component of velocity with respect to time, I hat, plus the derivative of our y component of our velocity with respect to time, j hat, plus the derivative of our z component of velocity with respect to time, k hat. Meaning that we would have an acceleration function of time that would have an x component of that acceleration with respect to time in the x direction I hat, a y component of the acceleration as a function of time, j hat, and a z component of the acceleration as a function of time, k hat. So it's exactly the same rules as kinematics in one dimension, only we can use this vector notation as a way of bookkeeping, and if need be, we can break it out into 3 separate single-dimensional problems. Thanks for watching.